So this will begin part 2 of our video series for Module 2 exam, where we're dealing with fraction notation and all things fractions. And so here we're going to look at equations with fractions and how to eliminate fractions from that process. We're going to look at mixed numbers, improper, and just operations with mixed numbers. So to get started, we want to look at, well, how do we solve equations when the coefficients of fraction? In the previous video, we looked at just keeping the fraction intact and subtracting the fraction from both sides or adding the fraction to both sides and then having to do some division of fractions. So that can get kind of tedious. There is a way to eliminate your fraction altogether, and that's using the idea of your lowest common multiple. So for instance, I look at this equation and I know I see 1, 2, 3, I see 4 terms. If I look at the denominators, I see 3, 5, and 1. 3, 5, and 1. Well, the lowest multiple of that would be 15. So what that means is if the LCM is 15, then I just want to multiply the entire equation by 15. And what that's going to do is create a new equation that's 15 times bigger than the one highlighted. Well, to do that, we need to use the distributive property and distribute and multiply 15 by each term. So what's 15 times 1/3 x plus 15 times 1/5 is equal to 15 times 1/5 x minus 15 times 1. Well, 15 times 1/3 is 15 thirds, which is 5x. 15 times 1/5 is 15 divided by 5, or 3. You see how already we've eliminated the fractions because we're creating integers. 15 times 1/5 x would be 15 divided by 5, or 3x, and then minus 15 times 1, which is 15. This is a whole lot easier to work with now with just the integers. So you're going back to what you were tested on in exam 1, and that is solving multi-step equations. And here we're just upped it a little bit where we've got variables on both sides. So you just need to decide which side you want your variables to be. Then that means the constants have to go to the other side. So if I'm going to subtract 3x here, then I need to subtract 3. So notice that I moved my constants to the right, but I moved my variables to the left. They need to go in opposite directions of one another. So if 5x minus 3x is 2x, this goes to 0, this goes to 0. I'm adding a negative 15 and a negative 3, which gives me negative 18. Now I need to divide both sides by 2, so x would be negative 9. The next slide goes through that whole process step by step. So you can kind of look at the process here, or you can rewind the video of me going through that as well. So let's do this. Let's take one of these at a time, and let's break it down with eliminating the fraction. But let's look at the LCM. So again, I see 1, 3, and 5. I'm going to use 15 again. So my LCM here is going to be 15. So 15 times 2/3 is going to be 30 thirds. Remember, that's your whole number multiplied by a fraction. So 15 times 2 is 30. 30 thirds. 15 times x divided by 1 is going to be 15x. And 15 multiplied by 4/5 is going to be 15 times 4, which is 60 fifths. And that's going to be 12. And 30 thirds is going to be 10. So I'm going to subtract 10 from both sides, and I'm going to get 15x is equal to 2. So x is equal to 2/15. I would have to divide by 15 on both sides. All right, let's look at this one now. We've got 3/4 x minus 1/8 equals 1/2. So I'm looking at fourths, eighths, and halves. And I can make all of those denominators 8 because I can multiply 4 by 2 and 2 by 4. So I want to use 8 as my LCM here. So 8 times 3/4 x, well, that's going to be 24/4 x. 8 times negative 1/8 would be negative 8/8 is equal to 8 times 1/2, which is 8/2. Well, 24/4 is 6x. 8 divided by 8 is 1. 8 divided by 2 is 4. So I want to add 1, and that's going to give me 6x is equal to 5. Divide both sides by 6. X is going to be 5/6. So we're going to multiply the entire equation by the LCM. And then that's just going to help us clear out the fractions to work with whole numbers. It's not a trick. It's using the LCM to your advantage. You're just creating a new equation that is however many times bigger than your original. Well, if the LCM is 8, then you're creating an equation that's 8 times bigger than your original. If your LCM is 15, you're creating a new equation that's 15 times bigger than your original. So let's look at this one here. I see 2, 5, and 10 as my denominator. So halves, fifths, and tenths. And I can make all of the denominators 10. So we're going to multiply each term by 10. So 10 multiplied by 1/2 x minus 10 times 1/5 is equal to 10 times 7/10. Now I'm putting in an extra step, which is I'm showing my work of doing the multiplication of 10 times 1/2, 10 times 1/5, 10 times 7/10. If you already know what that result's going to be and you're confident in that, then you can skip that step and go ahead and go directly to the result. And so 10 times 1/2 x is going to be 5x. 10 times 1/5 is going to be 10 divided by 5, which is 2. And 10 times 7/10 is going to be 70/10, or 7. Add 2 to both sides. I get 5x is equal to 9. Divide by 5. X is equal to 9/5. And you can leave it as an improper. And then finally here, I see thirds, halves, and fourths. So the LCM would be 12. And just for a heads up, sometimes students like to look at the thirds, halves, and fourths and those numbers and multiply them and get 3 times 2 is 6 and 6 times 4 is 24 and use 24. Just remember that 24 is a multiple. It's not the lowest, but that's okay. You just know that you're going to probably do some simplifying. But if you wanted to use 24 by just multiplying 3 times 2 times 4, that's fine. You could look at the top one up here, 2 times 5 times 10. Well, if you used 100, that's okay. 100 is just not your lowest multiple. And then you would have some simplifying to do in these steps here. So if you want to use 24, and maybe you were taught that before, is just take these and multiply them, that's fine. We can look at that method as well. There's just a little bit more multiplying going on here. So 24 multiplied by negative 13 thirds x minus 24 multiplied by 11 halves equals 24 multiplied by 35 fourths. So in this case, I don't really want to multiply that 24 by 13 out right now. I know that 3 is going to divide 24 8 times. And 8 times a negative 13, that's going to be 80, and 24. So that's going to be what, negative 104x. So that's another way to look at that, because I know, well, 24 times 13 is 312. 312 divided by 3, I get the 104x. I just noticed, I see that 3 will divide 24, so I'm just simplifying in that way. 24 times 11 halves. Well, I know 2 will divide 24 12 times, and then 12 times 11 is 132. You see how sometimes when you use a larger multiple, you do create a little more multiplication, but it doesn't matter. It's all going to work out. And then 6 times 35 is 180 and 30, or 210. So again, I'm just going to add 132. And that's going to give me 342. And then the 342 divided by 104 is about 3 28/100. So, and sometimes they can get a little complicated like that. That's not my goal for you, is for it to be overly difficult with the multiplying and the dividing. I just used some larger numbers just so you could see through the video. So you do have practice here, especially be mindful here. If you're going to look at practice with solving equations and you want to clear the fractions, that'll be good practice. And then, you always have my videos, but you might want to look at videos elsewhere, and so that's why I offer you those options. Next, we want to look at converting mixed numbers and improper, kind of going back and forth from one form to the next. And then we want to look at adding and subtracting with mixed numbers. So remember what a mixed number represents. It's the sum of a whole number and then a fraction that's less than 1. So when you look at this picture here, you see that that's a whole, and that's a whole, and this isn't quite a whole. And so we have sevenths, but we have 6/7. So we can add those together to give us the 2 plus the 6/7, which is also known as 2 6/7. That mixed number is just showing you're adding the whole plus the fraction. And both of these are correct. So it doesn't mean that it has to be written the way that you see and highlighted. This method is fine as well. However, that's the most common method that you're going to see with mixed numbers. So if I want to convert from a mixed number to an improper, there is a short method that simplifies your process, but I just want you to see why that works, okay? You've probably been taught, well, I multiply 3 by 6, and then I add 2. Okay, well, why do you do that? Well, how many thirds are in one whole? Well, there would be 3. Well, how many are in 6 wholes? Well, if I've got 3/3 in 1, I need 6 groups of 3/3. So that's going to give me 18 thirds. Well, what is 18 thirds? Well, that's the same as 6 plus the 2/3 that's there. So 18 thirds plus 2/3 is going to give me 20 thirds. That's my answer in an improper form. But let's go back to that first question I asked, is that you probably were taught 6 times 3 is 18 plus 2 is 20. Well, because what you're doing is you have 6 groups of thirds, and there's 3/3 in a whole. So you've got 6 groups of 3/3. 6 groups of 3/3 is 18 thirds. And 18 thirds plus the 2/3 that are there make it 20 thirds. So I just wanted to go through why you can do that shortcut before just giving you the shortcut. So 8 and 2/9, we see there's ninths. I need 8 groups of 9/9, which is 72 ninths plus the 2/9, 74 ninths is your improper. Here, just disregard the negative because you know the answer is negative. So just work it as if you saw it 4 3/4. Well, there's 4/4 in a whole. How many 4/4 in 4 wholes? That's 16/4 plus the 3/4. So you have 19/4, and we know it's negative. -7 5/6 was another one. And then what was the last one? 20 2/5. How many sixths are in 7 wholes? Well, there's 6/6, and in 7 wholes would be 42/6 plus the 5/6 would be 47/6, and I know it's negative because it began as negative. 20 2/5. Well, remember there's 5/5 in 1 whole. So how many 5/5 in 20 wholes? Well, that's going to be 100/5 plus 2/5. Well, remember that 100/5 is 20. That 42/6 is 7. And I can show the negative as well. So that's going to be at 102/5. So that's just changing from a mixed number into an improper. And then going the other way, if I want to convert improper into mixed numbers, so if I have 104, notice that I had on this last one, 102/5. So 102/5, I'm just saying how many times will 5 divide 102? And it would be 20 2/5, which is what we started with earlier. So here's where we're looking at some application with this. Find the average number of minutes you jog per week. So this would be 24 plus 30 plus 27 plus 32. And this would be the first 4 weeks of her routine. So find the average number of minutes she jogged per week. Well, you're dealing with 4 weeks, right? So you're going to divide by 4 to get that average amount. So when you add all those up, you're going to get 54 plus 59. So you're going to get 113 divided by 4. That's an improper. And so how many times will 4 divide 113? I'm going to come over here. I'm going to run out of room. This will be 33, 28. And I jump pages here. Okay. And so we said 28, and then so that would be I need to erase that part. So come back here. So it's 8 times 4 is 32. And then I'll bring down my 0 there. 4 will divide 10, so that'd be 2 times. Bring down another 0, so 4 will divide 25 times, so that'll be a 20 minus 20, remainder is 0. So 28 and 25 hundredths. So what's her average, Shelby's average time jogging per week is 28 minutes and a quarter of a minute over the 4 weeks. So with these, if we wanted to change from improper to mixed number, just remember you're taking your denominator and you're just going to divide your numerator. So we did a small version of this, right? We did some division on exam 1 and quiz 1, but here it's not that large of a number that we're dividing, and so the process isn't going to be that lengthy. So you're thinking 10 will divide 69 6 times, so 6 9/10 we would write as our mixed number. 8 will divide 122, so that would be 12 minus 8, 42. 8 times what gets me close to 42, and that would be 5, so that's 40. So 15 2/8 or 15 1/4 would be the same. How many times will 4 divide 9? We just know our answer is going to be negative. So that would be 2 1/4, and it's going to be negative. We know that negative 58 is going to be negative, so 8 will divide 56 times with remainder of 2, so 6 2/8 or 6 1/4. And then 227 fourths, make sure I copied that correctly, 227 fourths, 4 will divide 22 10s, 5 10s times, so that will be 4 will divide 27 ones, which would be 6 times. So 56 3/4 is equivalent to 227 fourths. So now let's look at when we're adding mixed numbers. I would encourage you to add up the fractional parts and add up the whole number parts. Can you change them both to impropers? Yes, you can. And it may be something that you want to look at when you're dealing with subtraction. But at this point, it's a lot easier to say 5 plus 4 is 9. And now I'm adding 3/4 and 5/6. Well, that LCM, that's going to be 12. So this will be 2 divided by 2. That's 10/12. And this will be 3/3. So that's 9/12. So 9/12 and 10/12 would be 9 plus 19/12, which is a form we're not going to use. 19/12 is an improper. So 12 will divide 19 one time and 7/12. So take your 9 and your 1 and you get 10, and take your remainder 7/12, 10 7/12. And of course, this is just a step-by-step with that. It's also using the change it to an improper method. And I really don't care which method you want to use. There's a lot of changing forms with changing to the improper, but if this was a method that you've learned in the past and you want to stick with it and you're good with it, then I'm fine with that. If you're subtracting, well, the problem with if you can subtract your fractions, that's great, but in this case you can't take away 3/4 from 1/4 without going into the negatives, but you can subtract your whole numbers, but you just can't subtract your fractions. So there's got to be a regrouping model here. And so in this case, you may want to notice that we took a whole away from 7 to make it 6. Well, what did we add? We had to add that whole over here. So this 1/4 and 4/4 made the 5/4. Now when you look at that, now you can subtract these. So 5/4 minus 3/4 would be 2/4, and 6 minus 1 would be 5. So you've got 5 2/4 or 5 1/2. So let's do some practice with that. Since we're these two, we're going to look at the addition first. So I would take the 2 and the 6, and I would make that 8. And now I'm adding 7/8 plus 5/8, and so the denominators are the same. So that's going to give me 12/8. And so let's just change 12/8 into an improper. So that's going to be 1 4/8 or 1 1/2. So I've got 8 plus 1 plus 1/2. So 9 1/2 would be my answer. Let's come over here and look at this one. So I can add 4 and 6. That's going to give me 10. But then I've got 3/8 and 5/12 that I need to add together. So 24ths would be your LCM. So I'm going to multiply by 2 divided by 2, 3 divided by 3. So that's going to give me 9 24ths plus 10 24ths plus the 10. Well, remember 9 plus 10, that's going to give me 19 24ths plus 10, or 10 and 19 24ths. So let's look at 5 and 1/8. Take away 2 and 3/8. Well, I can't take away 3/8 from 1/8 without going into the negatives. So I want to regroup and I want to take a whole amount. Well, since the denominators are the same, I'm taking that whole amount, which is 8/8, and adding it to the 1/8. So now I have 4 and 9/8 to take away 2 and 3/8. And I would do the same process if the denominators were different. But here I can say, well, I can do this. 9/8 minus 3/8 would be 6/8, and 4 minus 2 would be 2. So 2 and 6/8 is the same as 2 and 3/4. And then let's look at 19 minus 5 and 3/4. Okay, so I don't have, if you notice, I don't have anything for that to take away that 3/4 from. So I'm going to take one whole from the 19 and make it 18. And now I've created the 4/4. See, that was the whole that I took away. I just regrouped everything. So I don't have 19 wholes now. I have 18 wholes and 4/4. Well, 18 plus 4/4 is 19. So I just did some regrouping. Now I can subtract. 4/4 take away 3/4 is 1/4. 18 take away 5 is 13. So let's look at some where we're subtracting with integers. So I've got 21 and 1/6. Subtract 13 and 3/4. So I do not have the same denominators. So what I want to do is just recreate that. I want to find my LCM, okay? So 6 and 4, we're going to get to 12. So this will be 21 and 2/12 and 13 and 9/12. So notice I didn't have the same denominators, but that's okay. We've had that practice with using the LCM method to do that. So now I've got 21 and 2/12 minus 13 and 9/12. It's very similar to what I've had a couple of slides ago. I can't take away 9/12 from 2/12 without going into the negatives. So what am I going to do? That's right. I'm going to take away a whole from 21 and make it 20. But what am I adding over here? I'm adding a whole, which is 12/12. So now that's going to give me 20 and 14/12. Take away 13 and 9/12. I can do this now and stay positive. So 14 take away 9 is going to be 5/12. 20 take away 13 is going to be 7 and 5/12. Let's look at this middle one, -4 and 1/6. And -5 and 2/9. Well, you're just adding those together, right? And those go back to our integer rules. We know the answer is going to be negative. When we add a -4 and 1/6 and a -5 and 2/9, we're adding two negatives together, so it's going to be negative. So let's think about our LCM. 6 and 9 would be 18. So I'm going to multiply this by 2 divided by 2, 3 divided by 3. So negative 4 and 3/18, and negative 5 and 4/18. So I just want to add these together. I'm not subtracting, I'm just adding these together, and they're both negative. So I know that's going to be negative 9. And then I know this is going to be 7/18. We're adding the numerators. And then the last one, we notice we've got negative 7 1/3. Negative 7 1/3. And we're going to subtract negative 5 1/2. Well, remember, if we go back to our first exam, if we use the additive inverse, we can change the subtraction to addition, but we've got to take the inverse of negative 5 1/2, which would be 5 1/2. So now I've got negative 7 1/3 plus 5 1/2. And I am adding, so I can just going to rewrite that form before I begin. So if you go back to exam 1 and that idea that what happens when you're subtracting integers and this, or adding integers and the signs are the same. And then what happens when they're different? Okay, well, here's an instance where negative 7 plus 5, they're different. So we would actually subtract, right? And keep the sign of the largest absolute value. Well, we're going to take that same idea, okay? So what I want to do is I'm dealing with thirds and halves, so I need to find the LCM, and that's going to be 6. So I'm going to get negative 7 2/6 plus 5 3/6. All right, so I can do this now, but the signs are different, so I'm going to have to do the subtraction, but I can't take 3/6 from 2/6 and stay negative. So I'm going, or stay positive. So I'm going to regroup here, take a 1 to make it negative 6, and I'm going to add 6/6 here. So what I have over here is negative 6 8/6 and 5 3/6. So 8/6, 3/6, that's going to give me 5/6 when I subtract. So I'm going to get negative 1 5/6. Now, there's negative 7 1/3, and 5 1/2. You can look at that as working with mixed number, improper if you wanted to. You could change this, and that would be negative 22/3. I'm just changing negative 7 1/3 to negative 22/3. And then 5 1/2, I'm going to change it to 11 halves. Well, I need to get a multiple, right? I need my least common multiple of 6, so I'm going to multiply this by 2 divided by 2, and this one by 3 divided by 3. So this will give me 6, and it'll give me 2 times negative 22 to negative 44. So if you want to do the improper method here and change it from a mixed number to an improper, and then do your operations, that's fine. That's going to give me 33/6. So now I see that the signs are different, so I'm going to subtract. So 44 subtract 33 is 11. That's going to give me 11.6, but I know that the largest absolute value is negative 44, so I know my answer is going to be negative. And then 6 will divide 11 5 times, so negative 1 and 5, 6, which is what we found on the page before. So there's some additional practice with adding and subtracting mixed numbers if you need that. All right, so we're going to push through to this last part here. Operations with mixed numbers. We're going to look at multiplying and dividing, and we're going to look at dealing with complex fractions. So when we multiply and divide with mixed numbers, we're going to have different methods, and I'm going to show you a couple different methods, and you choose what makes sense to you. One method is to multiply the mixed numbers, convert them to fractions, and then multiply. So if we're looking at the chef of a 5-star hotel is doubling a recipe for chocolate cake. So the original recipe was 2 3/4 and of flour and 1 1/3 cups of sugar. So this chef is doubling the recipe. Well, the original recipe had these. So what we're going to do is just multiply both by 2. Well, you can't just say that that's 4 3/4 and 2 1/3. You can't just multiply the whole numbers together. So if it helps you, then change the 2 3/4 to an improper. So 4 times 2 is 8 plus 3. That's 11/4, and we're going to multiply by 2. And it says how much flour and sugar, so we're looking at adding these together. Well, 1 1/3 would be the same as 4/3, and we want to multiply it by 2, but we want to add our results. So 2 times 11/4 would be 22/4, plus 2 times 4/3 would be 8/3. Well, 12ths will be our lowest common multiple, so I'm going to multiply 3 divided by 3 to 22/4, and 4 divided by 4 to 8/3. So this is going to give me 66/4 plus 12ths. And so then what we would take is the 66 and the 32, which would be 98/12ths. And then we would divide that to figure out how much sugar and flour is needed. So what, 8 times would be 96. So 8 2/12ths, or 8 1/6 cups of sugar and flour. So again, when you're multiplying mixed numbers, 8 multiplied by 2 5/6, let's change the 2 5/6 to an improper. So that would be 6 times 2 is 12, 12 plus 5, so that's 17/6. And then you can multiply 8 by 17 and then divide that, and then you would just divide that by 6. So 8 times 17 is going to be 136, and you're going to divide that by 6. So that'll go twice. And so 6 times 2 is 12. So 22 4/6, and 4/6 can both be divided by 2, so 2/3. So both of those are the same. If you look at part C, we've got 4 1/5 multiplied by 5 1/4. So I would change 4 1/5 to 21/5 multiplied by 21/5. So you would take 21 and multiply by 21. You're going to get 441 divided by 25. And so 25 will divide 44 one time. So that's 19. And then, so 25 will divide 191. So how many times would that be? Seven times. So 14, 18. And so what this will do, we'll just have to keep dividing out. So that would be so I should get about 17 and 17, but there's a mistake right here. Sorry about that. So that's 14, 15, 16, 17. I put an 18 there. I put 185, didn't I? So that's going to be 160. And that should divide, so 6 times. So that's 15, and then 4. So 17 and 64 hundredths as the result there. So, you get the 441 25ths. You could stop at and make that 17 and 16 25ths as your result here. I just wanted to take that to a decimal just to show you that. So dividing mixed numbers, we can look at converting again to an improper, and then we can use the reciprocal method or the common denominator method, whichever makes sense to you. So let's just go to some examples here. I've got 8 3/4. So I'm going to make this 32, 33, 35 fourths divided by 16 and 5, 21 eighths. Now, if you want to try the least common multiple method, I just need to make the denominators the same. And I can multiply by 2 divided by 2. So 35 times 2 is 70 eighths divided by 21 eighths. So when you get it to the common denominator method, you can see that 8 divided by 8 will go to 1, leaving you with just the numerator, which is 70 divided by 21. And so you can get it to your final result that way as well. And that would be 21 4 times. So 84 is too big. So 3 times, so 63. So that's 7. So we could say 3 and 7 21st, or 3 and 1/3. Now let's take the same problem, 8 3/4 divided by 2 and 5/8. And let's look at another method. So this is where we would use the reciprocal. So we know this is 35 fourths divided by 16 1/21 eighths. Now, just a side note, remember that if you had 16 divided by 2, you know that that's going to be 8. Well, 16 multiplied by something is also 8. Well, that something is 1/2. Notice that it's the reciprocal. 1/2 is the reciprocal of 2 to 1. So if you want to use and change to multiplication, you just have to multiply by the reciprocal. So 35 fourths is multiplied by 8 21st. Now, what I would encourage you to do is look at common factors that you can divide out. So 35 would be 7 and 5. And here we've got 4 and 8 would be 4 times 2, and 21 would be 7 times 3. I would just look for you to, you can diagonally simplify as well, so these 4s will divide out, and these 7s will divide out. So what you're left with is 5 times 2 is 10, and 1 times 3 is 3. So you have 10 thirds, which is the same as 3 and 1/3, which is what we found right over here. So let's take 3 1/3 divided by 2 3/5. And so let's look at the two different methods. Okay, so 3 1/3 is going to be 10 thirds divided by 13/5. So I changed them both to impropers. Now here I'm going to use your LCM method. Here I'm going to use the reciprocal method. Again, doesn't matter. You pick which makes sense to you. So I want to get my LCM to 15. So I'm going to multiply this by 5 divided by 5, and this one by 3 divided by 3. So that's going to give me 50 15ths divided by 39 15ths. Denominators are the same. 15 divided by 15, divide out. I'm left with 50 39ths, and 39 will divide 50 one time with 11 remaining. So 1 and 11 39ths is the result. All right, so if I did the reciprocal method, I would take 10 thirds and multiply it by the reciprocal of 13/5, which would be 5 13ths. Multiply, 10 times 5, I get 50. 3 times 13, I get 39. Notice you get the same answer. And if we do the division, we'll get the same. So use your method, whether that's the least common multiple method or the reciprocal method. Okay, if we're looking at order of operations, because the objective talks about order of operations with complex fractions. So when we do that, you're looking left to right like you did in exam 1 with your order of operations, but we're dealing with fractions now. So I've got addition, division, and multiplication. So what am I going to do first? I'm going to do the division first. So 2 thirds divided by 1/2. So use your method, whatever works. And I'm going to get 4 thirds. So now I've got 1/6 plus 4 thirds multiplied by 5/8. Now I see addition and I see multiplication. Well, I need to do multiplication next. So that's going to be 20 24ths. And now I need to add 1/6 to it. Well, I can make 1/6. I can make 6th into 24ths. I just need to multiply by 4 divided by 4. So that'll be 4 24ths plus 20 24ths, which is 24 24ths, or 1. So I got negative 1/2 minus 2 thirds, but also negative 1/2 to the second power. So if you're looking at this left to right, I see that this is negative. I'm dealing with subtraction. I'm dealing with multiplication and exponents. So I'm going to take negative 1/2 and square it, which is negative 1/2 multiplied by negative 1/2. What's a negative times a negative? So it's a positive 1/4. So now I have negative 1/2, looking left to right, negative 1/2 minus 2 thirds multiplied by a positive 1/4. I just simplified this piece right here to get to here. Now, subtraction or multiplication. Next, we're going to do the multiplication. So I'm just going to look at it at these numbers here. So I've got negative 1/2 subtract. This is going to be 2/12. And so I've got negative 1/2 minus 2/12, or additive inverse could be -1/2 plus a -2/12. So I'm adding these two negative fractions together. My answer is going to be negative something. Well, I can make 1/2 into 12ths. I just need to multiply by 6 divided by 6. So that's -6/12 plus -2/12, which would be -8/12 or -2/3. And then we'll look at one more before we end. So 1/2 minus 2/3 in the numerator, all divided by 1 7/8. So when you're dealing with these complex fractions here, I would go ahead and we're going to look at the numerator first. So we're going to take 1/2 minus 2/3. I need a lowest common multiple, and that's going to be 6. So I'm going to multiply this by 3 divided by 3. 2/3 I'm going to multiply by 1/2, or 2 divided by 2, excuse me. So that'll be 3/6. Take away 4/6. And so that's going to be -1/6. All right, so that's what I have left in the numerator, but I have to divide it by the denominator. So let's go ahead and change the denominator into an improper, which would be 15/8. Remember, 8 times 1 is 8 plus 7. 15/8. And 6 and 8 depends on your method. If I go lowest common multiple, I'm going to get to 24. So this will be -4/24 divided by 45. 15 times 3 is 45. 8 times 3 is 24. 24 divided by 24, so I'm left with -4/45. Now let's go back and look at this same approach with the reciprocal method. So -1/6 and divided by 15/8. If you want to use the reciprocal method, you would do -1/6 multiplied by the reciprocal. And so -1 times 8 is -8. 16 times 15 is 60, and 30, that's 90. And both are divisible by 2. So our -4 times 2 and 45 times 2. So these will divide out. You're left with -4/45, which is what we found with our other method. So that is operations with complex fractions, where we're looking at multiplying and dividing with mixed numbers. So I would encourage you to look at those videos, rewind this one, watch it as much as you can, and we will go through these in our future meetings. So this concludes part 2 of operations with mixed numbers, order of operations, and complex fractions.